In this video, we're going to apply Newton's laws to non-equilibrium problems. Okay, so far in the previous couple of videos, we looked at equilibrium problems. Here, we're going to be focusing on non-equilibrium problems. We already did a bunch of non-equilibrium problems in class the other day, so this is not going to be a big change. However, some of the problems might be a little bit more involved. We're going to introduce some new ideas as well. So let's go ahead. Let's try to apply this by using some examples. So let's say we have a block of say, I'll put the masses in 1 second. So let's say we have two blocks connected by a string that passes over a pulley and it's connected to a third block. Let's say this guy is M1, let's say this guy is M2, let's say this guy is M3. So we have three blocks and everything is frictionless. Okay, so there will be motion. And what's going to happen is when you release the system from rest, block M1 is going to start moving down and it's going to pull M2 and M3 along with it. So our goal is to calculate the acceleration of the blocks and also to calculate the tensions T1 and T2 in the strings. Okay, once again, the restriction to the answer is that each of these answers, A, T1, and T2, has to be in terms of all the things that are given, okay, which in this case are the three masses, and we could also have g, the acceleration due to gravity, in our answer. Okay, we cannot have anything else. A cannot be in terms of t1, t1 cannot be in terms of a or t2, and so on and so forth. So please make sure you understand that. Okay, so first thing, you all know what we need to do. So go ahead and draw the free body diagrams for each of the three blocks. Okay, I'm going to pause the video or no, sorry, you're going to pause the video and then come back and look at the diagrams. If our diagrams match, then we'll use those to go ahead and write our equations and then solve the problem. Okay, so pause. All right, I'm assuming that you drew your free body diagrams and I'm going to do the same right now. So this one is for M1. We have M1G pointing down, okay? And then since tension is going to be up and because M1G, we know that M1 is going to be going down, we know that M1G is going to be more than T1. That's why I have drawn that arrow drawn slightly shorter. Okay, let's go ahead and do the same for M2. For M2, we have two forces. We have the tension T1 pulling it to the right. Then we have the tension T2 from the other string pulling it to the left. And we also have forces along the vertical direction. We have M2G pointing down and we have some contact force, and let's call it Fn1 pointing up. Okay, so these are all the forces acting on M2. Now let's go to M3, and the forces acting on M3 are going to be T2 to the right, and then we have some M3G pointing down and some Fn3 pointing up. Okay, now as we discussed in class the other day, for blocks M1, M2, and M3, because everything is frictionless, okay, because they are not moving on a rough surface, Fn1 and M2G, they balance each other out. Fn3 and M3G also balance each other out. Actually, I'm just going to call this guy Fn2. There's no reason, just because the blocks are 2 and 3. Okay, so those two forces are kind of irrelevant for our situation. But I'm just putting them because if you're told to draw a free body diagram, then this is what you would have. You would have nothing else added to the free body diagram. I hope that was very clear in class the other day. So what is our goal? We want to solve this equation. Now, in order to do this, what I suggest you do is draw a separate set of pictures along, with these diagrams, along with the dotted arrow. Okay, so let's do this very quickly. So I'm just going to draw M1. So for M1, we know we have M1G here, we have T1 here, and our dotted arrow is going to be a downward arrow with, if I hope you remember this, with mass of 1 times A, because Newton's law says F equals ma, Newton's second law. Okay. Similarly, for M2G, I'm going to have T1 to the right, I'm going to have T2 to the left, and then I'm going to have M2A to the right. I'm just ignoring the vertical forces because they're just going to cancel each other out and not really uh, have any impact on the actual acceleration. Similarly for M2, M3, we have T2, which is the only force, and then we have M3A pointing to the right. All right, so at this point, we are ready to start the equations, okay? So if your diagrams were not this, okay, but now that we have the diagram, what I suggest again, you pause here and set up your equations and see if our equations match. All right, so I'm assuming that you've paused, and let's write the equations for each of the blocks. I'll start with M1. Now, we asked two questions here. Who's winning? Okay, and or rather, no, first we ask which direction are we moving, and then that'll decide who's winning. So clearly for M1, it's moving down, and therefore the force pulling it down has to be greater than the force pulling it up. So we can write for M1, M1G minus T1 is equal to M1A. Okay. Similarly, for 2, we know that, oh, I have a G here, that shouldn't be there. So for 2, we see that the block 2 is going to move to the right, and therefore the force pulling it to the right has to be greater than the force pulling it to the left. So we have T1 minus T2 is equal to M2A. And then for 3, we only have one force, which is T2, which is equal to M3 times A. Okay. Now, I suggest that when you write these equations, you write them one below the other. Do not try to write one equation, one part of the one corner of the page, the other one another corner of the page, or don't try to write the equations under the free body diagrams. Okay, the best method here would be writing the equations one below the other. If you didn't do it, go ahead, erase your work and rewrite it, because that's the only thing I'm going to accept on tests and stuff. All right. So I'm assuming that you did that and you have these three equations. Now, the reason why we want to do this is, you see, we have to solve for A, T1, and T2. We have three things that we have to look for. Okay, we have three equations, so we should be able to solve this problem fairly easily. Now, if you write the equations one below the other, you're going to start seeing something. You see how in equation 1 you have a negative T1 and equation 2 has a positive T1. Similarly, equation 2 has a negative T2 and equation 3 has a positive T2. So you see, if we were to add up these equations, okay, just simply add them all up, what we would notice is that on the left hand side when we add, okay, the only thing that survives is M1G. And on the right hand side, we have our three masses, and we can write this as M1 plus M2 plus M3 all, and then we can factor the A out. Okay, you could write it as M1A plus M2A plus M3A, and then factor the A out. I just chose to do it in one step. Now we have the answer. We have A is equal to M1G divided by M1 plus M2 plus M3. Okay, so this is our acceleration, and like we said earlier, we can only have things that are given in the problem, and the masses were the things that were given in the problem, and we use the acceleration due to gravity along with that. Okay, so we solved for A. Now let's go ahead and solve for T1 and T2. Since T2 we know is simply M3 times A, let's calculate that first, and we can write this as M3 multiplied by M1G over M1 plus M2 plus M3, and now we have T2. Again, staying true to what we said originally, answers can only be in terms of things that are given. We can now go ahead. I'm just going to answer, or rather write the work for T1. We'll use the middle equation to find T1. We see that T1 is equal to T2 plus M2A. Okay, and we know that T2 is, okay, so let me write this first as T2 plus M2A. We see that T2 is equal to M3A, okay, and M2A. And now I can rewrite this as M2 plus M3 times A, and we already know what A is. So we have M2 plus M3 times M1G over M1 plus M2 plus M3. And we have the three things that we were looking for in the problem. Okay, now if you understand this problem, if you know what we did, then go ahead and solve this example, and let us see if we are able to do, if you're able to solve this by yourself. Okay, so in this one, we're going to have some mass m here. We're going to have m1, we're going to have m2, we're going to have m3. Let's call this string 1, let's call this string 2, string 3, and your goal is to find a, t1, t2, and t3. Okay, to get the answer, check with each other, and make sure, again, show all the work, show every step, write the equations one below the other, and you should be able to figure this out, you know, by yourself. All right, that's it for this video.